It is always inclined to the horizontal, right? Good. So the rough inclined plane makes an angle of what? 30 degrees with the horizontal. So now, where is the body? This is the body, right? Good. This is the reaction. This is the body acting downwards. So here we have mass of 40 kg. So we have 40 G. This G here stands for the force of gravity. That's 10 meter per second squared, right? Okay. So we were told that a force of 420 Newton is applied upwards. That's the pull. 420 Newton. Okay. And then we'll have our mg sine theta. While we have friction, force of friction here. This is our reaction, right? And then here we'll have our mg cos theta. So you see, I've done justice to this explanation. I've represented this in a diagram. So this 30, if I put it here or not, I'm still in order. All right. So now the next thing is for me to go ahead and solve. Okay, so now I'm looking for a maximum frictional force that will keep the body in equilibrium. Now, what do you think happens for this body to be in equilibrium? It means it is not going up. That means the force pulling it up is not greater than the one dragging it down. Or the one dragging it down is not greater than the one pulling it up. So there is a balance. And as a result of that balance, this body can stay here and not slide, because the force pulling it up is equal to the one dragging it down. So if you look at the force dragging it down, you see we have two forces dragging it down. We have the mg sine theta, and then we have the force of friction, right? Good. So for this body to be in equilibrium on this plane, it means that mg sine theta plus the force of friction will be equal to the pull, the force pulling it up, which is 420 Newton. So the mass is 40 times 10 sine 30 degrees plus frictional force, and that will give us 420 Newton, right? Good. So we have 400 sine theta is half times half, put in a bracket, plus the force of friction will give us 420 Newton. So this here will give us 200. So we have 200. There should be a Newton here because mg is already 200 Newton, right? Good. Plus frictional force is equal to 420 Newton. So if we collect like terms, since we are looking for frictional force, we will have 420 Newton minus 200 Newton, and that will give us 220 Newton. So we need a frictional force of 220 Newton to team up with mg sine theta so as to maintain equilibrium with what? The pull. All right. So the next question here says that we should find the coefficient of friction, which is mu. So the force of friction, coefficient of friction rather, is frictional force over the normal reaction. That's our R. Normal reaction. And that is equal to frictional force. We've gotten it to be 220 Newton all over the normal reaction And that normal reaction is equal to mg cos theta. Do you remember? Good. So what's our m? The mass is 40 times 10 cos 30, right? Okay. So we'll have 220 over 400 cos 30. And that will give us 0.635. Okay, now approximately 0.635 to 3 decimal places. Now, if you've been watching my videos, you would see me emphasize on avoiding premature approximation and then leaving your answer except you are asked to round up as the case may be. So now I'm going to give you one more question.